Assalamualaikum warahmatullahi wabarakatuh. Today's topic is topic number 2 on the concrete mix design for week 6. This topic will be presenting by Haslim Idayu Amaruddin. The lesson outcome, at the end you should be able to identify the specification for mix design. Then you need to explain the process of mix selection. Explain the factor governing the selection of mix, and also you need to able to calculate the mixed concrete design according to the OE method. So what is concrete mix design? Concrete mix design is the process of selecting the ingredients for concrete mixture and deciding on their proportion. So basic ingredients in mix design is cement, coarse aggregate, fine aggregate, and water. The goal is basically we are going to provide a concrete mixture that is adequate in workability, adequate strength, adequate durability, but with minimum cost. Factor governing the selection of mix is depending on the grade of concrete that we are going to produce, type of cement, type of size and grading of aggregates, water cement ratio, workability, durability, compressive strength, and also the aggregate cement ratio. For concrete mix design form, we have unrestricted design, restricted by maximum or water over cement ratio, or restricted by maximum water over cement ratio and minimum cement content, and also can be restricted by minimum cement content or restricted by maximum cement content, or also air entrained concrete. Okay, so this is a design form which is for unrestricted or restricted design. Okay, so this form has 5 stage altogether, so we are going to look into each stage. So concrete mix design step, basically we have 5 steps, which is the first step is the strength leading to the free water cement ratio, and then we are going to work on the workability leading to the free water content, and in step 3 the result of stage 1 and 2 we will get the cement content. And step number 4 is determination of the total aggregate content, and step number 5 is to find the fine aggregate and coarse aggregate content. Okay, so let's look into one example. Let's say you have to propose a concrete mix design for unrestricted design. So the following requirements are specified. So the first one is compressive strength at 28 days is required strength is 35. Proportion defective is given 1%. Then cement type we are going to use as RPC. Maximum aggregate size is 10 mm. Aggregate type we have coarse aggregate, crushed, and uncrushed fine aggregate. The slump requirement is 100 mm. And the relative density is given as 2.65, and grading of fine aggregate percentage passing through 600 micrometer sieve is 60%. And then you need to compute the batch weight for each ingredient that you will use to cast 3 cube size and also 2 prism size, including 10% wastage. Okay, so first step. The first step will deal with the strength, standard deviation, margin, and then you need to find the target mean strength and also the free water cement ratio. Okay, so stage 1, so this here is the first one is the characteristic strength. So what is your characteristic strength? So we are going to propose a 35 megapascal at 28 days, and given here the proportion defective is 1%. Okay, so next we are going to find what is the standard deviation based on figure 2. Standard deviation is basically given by this equation. However, we are going to use figure number 2, the simplified relationship between the standard deviation and characteristic strength. So here we have two curve A and curve B. Okay, so which one we are going to use? It depending on your strength test. Let's say we have the previous information concerning the variability of strength test is less than 20, then we are going to use line A. If the previous information is available consisting of 20 or more, then we are going to use line B. Okay, so it depends on previous information regarding the test that we have. So let's say we don't have the previous information, then it is suggested to use line A. Okay, so from line A, since our characteristic strength required is 35, so from here at the center, so you project to the line A and get the maximum standard deviation value equals to 8. Okay, so we put here 8 value for standard deviation. Okay, next we move on to margin. Margin is specified, or we refer to C1. Okay, so what is margin? Margin basically, as a result of the variability of the concrete production, it is necessary to design the mix to have a mean strength greater than the specified characteristic strength. It means that in mix design, we are going to design the strength should be higher than the proposed strength required. Okay, so basically margin is the K value, a constant value times the standard deviation. For concrete strength, basically we are following the normal distribution, which is this curve is idealized distribution of value of compressive strength for a sizable number of tests. Okay, so means here, let's say if our characteristic strength is 30, the mean strength should be depends on some margin to get the mean strength. Okay, so here the margin. So how do we calculate the margin? Margin K value, the constant value, is given based on your proportion defect. Since from the equation it given that we have 1% defect, so that means K value is equals to 2.33. This table is taken from BS 532A. So then you calculate your margin. Our K value is 2.33 times the standard deviation, so you get 18.64. So you run out equals to 19. Okay, so and then you can calculate your target mean strength. Target mean strength is given as the characteristic strength plus the margin. Okay, so here the calculation, since our characteristic strength is 35 and the K value is 2.33 and S value is 8, then we get our target mean strength equals to 54 Newton per millimeter squared. Okay, so here you put your target mean strength, which is 54. And then you select your cement type, since we are going to use SRPC, and our specified aggregate type, because aggregate is crushed and fine aggregate is uncrushed. So normally fine aggregate is uncrushed because we are going to use a river sand. Okay, so next is to calculate the free water cement ratio by referring to table 2 and figure 3. Okay, selection of the target water cement ratio is obtained from table 2 and then we plotted on figure 3. Okay, so here is table number 2. Since we are going to get our compressive strength for 28 days, and for type of cement is sulfate resisting Portland cement, SRPC, and type of coarse aggregate is crushed. Okay, so we get the value of compressive strength is 49. Here, the 49 value. Okay, so next we refer to figure number 3, so which is the relationship between the compressive strength and free water cement ratio for DOE method. Okay, so here is the starting line using the data. Okay, so from the previous table, we get the compressive strength is to be 49. Okay, so 49. So then we project value of 49 to the starting line here, and then you draw another curve, intersect at the here at the starting line. Okay, so the new curve, and then we have already calculated our mean target strength, which is equals to 54. Then you project to the new curve, and next you project to get the free water cement ratio. So here approximately we get 0.46 free water cement ratio. Okay, so for maximum free water cement ratio, this one is given in BS 8110. Is given here for lowest grade of concrete. For example, since we are going to design for C35, the water cement free ratio is maximum water cement free ratio equals to 0.6. Okay, so we substitute into the form all the values. Okay, so free water cement ratio equals to 0.6 and maximum free water cement ratio equals to 0.6. Then use the lowest value, which is 0.46. Okay, so then we move on to stage number 2, which is you need to select the free water content from table 3. Okay, so this is table 3, which is the approximate free water content. Depends on workability, required workability. Okay, so the first row here is the slump value. Required slump is given in the equation, which is we require 100 mm slump. So here is the range. Okay, so our maximum size of aggregate is 10. So we will have our value is here. So since we have uncrushed and crushed aggregate, then you have to calculate the free water cement ratio using this equation. Okay, WF this the water content for fine aggregate, and this one is for coarse aggregate. Okay, so you just calculate using this formula and you get your free water cement ratio equals to 233 kg per meter cube. Okay, so you substitute into your design form in stage number 2. So we complete design stage number 2. And then we move on to step number 3, which is you need to determine the cement content. Cement content is free water content from the table, the previous table. Then you divide it by free water cement ratio from stage 1. Okay, since we have our cement ratio is equals to 0.46 and free water content equals to 233, so then our cement content is equals to 507. So means 233 divided by 0.46, then you get 507. Okay, so you just put here inside your stage number 3 in the form. Okay, so cement content we get 507. For maximum cement content, this one is not required. Here is also not required, and here also you don't have to do anything about this one. Okay, then we move on to step number 4, which is we need to determine the total aggregate for the mixed design. The step require an estimate of density of the fully compacted concrete obtained from figure number 4, and it's depend on the free water content and the relative density. Okay, so let's say we don't have the value of relative density, then we can assume the value to be 2.6 for uncrushed aggregate and then 2.7 for crushed aggregate, and then you refer to figure number 4. So here is figure number 4. Since in the equation it is given that the relative density equals to 2.65, and our estimated this figure is actually for estimated wet density. Since our free water cement ratio we get 233, and our relative density equals to 2.65, which is in between these two lines. So you just draw another line here for 2.65, and then at the intersection, then you project the line to get your fresh density of concrete mix. Okay, from here we get our wet density equals to 2375. To determine the total aggregate, the wet density that we get, you need to minus with the cement content and also the free water content. From previous step, we get that the cement content is equals to 507 and our free water content equals to 233. Then total aggregate content is equals to 1635. Okay, so you substitute into the equation here. Relative density equals to 2.65. Our concrete density based on figure 5, we get 2375. And our total aggregate content is 1635. Alright, so then we move on to stage number 5, which is the selection of fine and coarse aggregate. Okay, so this one is, we need to calculate what is the percentage of fine aggregate. Given that the percentage fine aggregate passing through 600 micrometer is 60%, and we know that the maximum aggregate size is 10 mm, so we are going to use figure 5a, and our slump is 100 mm, so this is the chart that we are going to use. The x-axis is the free water cement ratio. Our free water cement ratio is 0.46. Okay, so here. Okay, so and our percentage passing through 600 mm is 60%. So from this intersection point, you project your line here, and you will get your proportion of fine aggregate in terms of percentage. So means 44% of fine aggregate. Okay, so this is a other table for, let's say you are going to use maximum aggregate size 20 mm, so you are going to use this table for 40 mm for this table. Okay, so to calculate the fine and coarse aggregate, since we have our percentage is 44% and our total aggregate content is 1635, so our fine aggregate is 719.4. So you just run off so that we get 719 kg per meter cube. The coarse aggregate content is the total aggregate minus the fine aggregate content, then you get your coarse aggregate content. Okay, so we put here in the form, so you get your proportion of fine aggregate, your fine aggregate content, and your coarse aggregate content. Okay, so basically we already calculate all the required ingredient to mix concrete. Okay, the selection of fine and coarse aggregate can be subdivided. Let's say we are going to use two size of aggregate, coarse aggregate, then you can use the ratio is 1:2, or you use 3 size of aggregate, then you can use this combination. Okay, so back to our design example. So here, after we get all our material content, the proportion of our concrete mix design, then you have to compute the batch weight for each ingredient to cast 3 cube size and 2 prism size, including 10% weightage. Okay, so to calculate this one, so first you have to calculate the volume. So you calculate the volume of 3 cubes and also 2 prism, and then plus 10% wastage. So you are going to get your total volume equals to 0.0143 meter cube. Okay, so here is the quantities that we get. the red one is actually the original value that we get from the form, the mixed design form just now. Okay, so but this one you need to round out to the nearest 5 kilos. Okay, so here the cement is 510, and then you get water is equal to 235. Your fine aggregate is 720, and your coarse aggregate is 920. Okay, so for quantities in kilogram, for each trial mix, for volume equals to 0.0143 meter cube. So means here, the value here, the black one, you have to time with the volume. Then you get your quantities in kilograms. So here you get your cement equals to 7.3 kilos, water 3.54 kilos, fine aggregate 10.3 kilos, and coarse aggregate 30 kilos. So these are all the required quantities to make 3 cubes and 2 prism. Okay, so based on the mixed design that we have done. Okay, so basically that's all about concrete mixed design. Okay, so we are going to continue on next lecture about the fresh concrete properties. Okay, that's all. Thank you very much.